All right, my friends, welcome back. This is day 12. We are skipping example 3, so we're jumping to example 4. So yeah, let's go ahead and get started. It's kind of similar to last time. Honestly, in my opinion, it's easier. We just have one new concept that we need to learn first. So the formula that we used last time was the big compound interest formula, and that looked like this, where we had, it could be plus or minus. You guys did great on that one. So principal value and then the rate divided by the number of times it's compounded. And we learned that this number, that the bigger it is, the more money that we get, right? We learned that compounding monthly 12 times a year was more money than compounding annually, which was only 1 time a year. So obviously you're thinking like, okay, well, if it gets compounded daily, that's 365 times a year. That's awesome. But what if you could do better than that? What if you could have it compound twice a day and now the n is in the 700s? Or if you had it compound 3 times a day and now n is in the thousands? That is like the concept of that. Instead of doing 3 times a day, 5 times a day, 20 times a day, 1,000 times a day, the best form of interest is if it's compounded continuously. Continuously. Compounded continuously means that the interest is compounding at every single moment of the day. Every millisecond, the interest is compounding. So, in fact, we don't use an n term when we talk about compounded continuously. We actually need a mathematical letter E. So when something is compounded continuously, instead of using an n, because we don't know that n, we as human beings can never write an n that big that represents that number. So we use the E value, which is very similar to the pi, okay? So E is a number. E is like pi. E has a value of 2.71 and then it goes on forever, okay? So the decimal goes on forever. You can find it on your calculator by pressing the second and then the divide button. So if we take a look at our calculator, if you do second divide, you get E, and if you hit enter, you'll see it's 2.71, 828182885, continuing on forever, just the same way like if you type in pi, and it's got a value, and it's a decimal that goes on forever. So we actually use E, not calculator, we use E in our new, so we have the compounded interest formula. Now we have a separate formula for when it's compounded continuously, and it's actually easier, okay? So A is still A, P is still P, but now we use that E, and the exponent of the E is going to be the rate times time. So yes, people call this the A-PERT formula, because that's what it spells. And yeah, so the A is still your final value. P is your principal value. E is E. Remember, it's not a variable, it's its own number. R is the rate as a decimal. And T is time. So it actually makes these equations really, really easy. So remember last time we had that table of n values and we had all of those things listed. And so if we saw monthly, then n was 12. If we saw quarterly, n was 4, and so on. Now, whenever you see the phrase compounded continuously, you're going to select E. So there is no n, it's E, and you're going to use this equation. Okay, so this is your magic phrase. When you see compounded continuously, that means to use the A-PERT formula. So really easy though, and if you guys do it on your own too on the target, you should do really well with it as well. The final value will happen when I take the initial $12,600 invested times, well, actually I don't need parentheses anymore, times E to the rate, move this 2 to the left, or do 3.2 divided by 100, and you get 0.32 times the time after 12 years. And that's it. That's all you need. You can type that in your calculator because E is a number. So let's go take a look at that. 12,600 times E, caret button, 0.032 times 12. And there's my answer. 8,400, and we can round to 99. So the amount in the account after 12 years is going to be $18,499 approximately. So again, compound interest is the best. This person put $12,600, Regina, that's her name, put $12,600 into account and walked away. She did nothing. She did not open her banking app. She didn't ask them anything. She didn't put any more money in. And 12 years later, that money made her about $6,500 by just existing in this account and being compounded continuously. And so that's your final answer. The only thing that changes is the starting value, the rate, or the time that they give you. So you guys should be really good and able to do these on your own. Again, email me if you have questions, or if you just want to chat, or if you just want to say hi. I'm missing you guys. It's been a really, really long time since we've been in school. So reach out just to say hi or anything that you guys need. All right, love you guys. Bye. Oops.